high-powered rockets, astronauts training for worst-case scenarios, the Hubble telescope, and even the Mile High Club.
What do they all have in common? A gyroscope. But it's not just space and sex. Gyroscopes are also in your phone, on your wrist, and in the car.
In simple terms, a gyroscope is a device that resists changes to its orientation thanks to a wheel that spins freely around an axle. So how did the gyroscope go from rockets to pockets? Well, it all started with the iPhone.
We're adding a 3-axis gyro that's built into every iPhone 4.
That was back in 2010, but the gyroscope's building blocks have been around for a lot longer. But it wasn't until 1744, when the HMS Victory set sail, that the gyroscope really started to take shape. Scientist John Serson noticed that a spinning top stayed level even when the surface was tilting, which made it ideal for an artificial horizon even on rough waters. Unfortunately, Serson, along with his invention and crew, were all lost, and his idea was pretty much forgotten about until 100 years later. Leon Foucault's prototype used a spinning disc, mounted in gimbals with pivoted supports that kept its orientation no matter how the base moved. So the modern gyroscope was finally born, but no one really knew what to do with it, until the torpedo nearly half a century later. Suddenly, the gyroscope started to find its feet. A new steering mechanism boosted the torpedo's range from hundreds to thousands of yards. Development really started to accelerate during World War I when inventor and industrialist Elmer Sperry replaced magnetic compasses with gyro compasses on warships. Which brings us surprisingly to the Mile High Club. Sperry's son Lawrence made a smaller and lighter version of a gyro compass that went into the first autopilot system back in 1916. The story goes that he and a lady friend were, shall we say, otherwise engaged, when they accidentally disengaged the autopilot, crashing in the water off of Long Island, New York. Rescuers found them alive and well, but totally naked. Although they insisted the force of the crash tore their clothes off, they are now widely believed to be the first members of the Mile High Club. Those same gyro compasses found their way into German V-1 and V-2 rockets during World War II, helping keep them on target. Gyroscopes and autopilot leapt forward in the 1950s with the invention of push-button airplanes, planes that were essentially able to fly themselves from takeoff to landing.
The plane taxis down the field and the throttles are operated by the mechanism for an increase of speed, whereupon the wheel is brought back in robot fashion for the takeoff.
It wasn't long before NASA put the gyroscope to work, strapping astronauts in training into this massive gimbal rig. The goal? Teach them to regain control of an out-of-control spacecraft. It might look like a carnival ride, but legendary astronaut John Glenn described it a little differently.
I guess you'd call it the weirdest training we ever did. We grew to hate that gimbal rig passionately.
And of course, the gyroscope soon started spinning out of this world. These stunning images from space wouldn't be possible without 3 of the world's most advanced gyroscopes that help point the Hubble telescope at its target.
Like other technologies, gyroscopes kept getting smaller and smaller. But it wasn't until microelectromechanical systems, or MEMS, that the gyroscope and accelerometer could get small enough and cheap enough to fit into things like airbags. MEMS are tiny devices that combine mechanical and electrical components, so basically a chip with moving parts.
These microscopic gyroscopes work the same way as the bigger gyroscopes. There's still a mass that's in motion, vibrating in the case of the small MEMS gyroscopes, and that is then used to measure angular movement thanks to the Coriolis effect.
MEMS also ended up in cars, partly thanks to something called the moose test. In 1997, Mercedes-Benz invited journalists to test drive the new A-Class to see how well it avoided a suddenly appearing obstacle, like a moose. The car didn't do so well, and Mercedes went back to the drawing board, modifying the chassis and adding ESP, or electronic stability control, as standard. With input from sensors like the gyroscope, ESP can detect if the car is skidding and help it get back on track. Before the A-Class, it was normally reserved for much more expensive cars. But it was the company that brought us Mario that really helped popularize MEMS. In 2006, the console wars were on, and Nintendo was really struggling to compete with the PlayStation and Xbox. And then
We would like to play.
they released the Wii.
Thanks to MEMS, the Wiimote could track its own relative motion, which opened up a whole new world of interactive gaming. And that brings us back to the iPhone 4.
Apple was the first to put a gyroscope in a phone, and along with the accelerometer, the iPhone could now detect motion on 6 axes. Mobile gaming was only just starting to take off back then, and the gyroscope suddenly turned the industry on overdrive. Apart from gaming, it's actually used for a lot more than you might first think, like straightening a photo in Instagram, showing you what that new sofa might look like in your living room, or keeping your low-light photos sharp with optical image stabilization. Unless you have arms of steel, your hands probably shake a little bit when taking photos, so the gyroscope detects movement and the camera system shifts accordingly to avoid motion blur. And it's not just phones. Gyroscopes in smartwatches like the Apple Watch can even tell the type of swimming stroke you're making, or know when you've fallen and can call for help.
And where are gyroscopes taking us in the future?
Set to launch in 2021, the James Webb Space Telescope will use so-called wine glass gyroscopes to look deeper into space to help find the first galaxies. Instead of mechanical gyroscopes like those used on the Hubble, these ones work in a vacuum and don't have any moving parts.
And researchers at the University of Michigan have developed an entirely new design that they say is 10,000 times more accurate than the gyroscopes we currently have in our phones. That could mean even more precise indoor navigation and accuracy for autonomous vehicles when there's no GPS, like when driving through tunnels. Pilotless electric air taxis, Hyperloop transportation systems, and electric hover bikes. Whether up in the air or on the ground, motion sensors will be a key part of bringing science fiction closer to reality.